Okay, in today's lesson, it's about selecting the correct procedures for determining limits. We're not really learning new information. We're just kind of putting together all the information we've been doing into just kind of a quick review video. So I'm just going to talk about, it's like our 4-step plan. Plan A, B, C, and D. And I'm going to give you some questions just to kind of review, and you can kind of pick and choose which ones you want to try on your own. So to start, plan A is always look, can I do direct substitution? Which means, boom, I can just plug it in. I don't have to do anything special other than just plug in the limit value as x approaches that value. And we're going to do this for continuous functions. So 2 examples. 1, the limit as x approaches 2 of x squared plus 3x. Basic polynomials, there's no fraction, there's no variable in a denominator. We can just plug that in. And then the next one, the limit as x approaches pi over 4 of sine of 4x. Another, it's a basic trig function. It's continuous. So just plug it in. So go ahead, pause the video and try these on your own. So for the first one, we should get 10, and for the second one, we should get 0. Okay, so plan B, if I can't just directly substitute it in, if something happens where I get a 0 in my denominator, you look to see if you can factor and then cancel, and then plug it in. So here are 2 examples. First one, limit as x approaches 2 of x squared plus x minus 6 all over x minus 2. So if I plug in 2, I'm going to get 0 in my denominator, so that's when I need to look to factor and cancel. And then here's another example. The limit as x approaches -2 of x cubed plus 8 over x plus 2. So I put this one on here so that we could practice factoring the sum of cubes. So go ahead, pause the video, and try these ones on your own. For the first one, you should get 5, and the second one, 12. Okay, plan C. So using algebra to kind of change, manipulate, and then to simplify, and then plugging in your limit. So we're looking at the 2 examples that come to mind are the complex fractions and the radicals. So here are 2 examples. Limit as x approaches 0 of 1 over x minus 6 plus 1 over 6 all over x. And the other one, the limit as x approaches 13 of the square root of x plus 12 minus 5 all over x minus 13. So pause the video, try them on your own. Okay, you should get -1 over 36 and 1 over 10. All right, and now the 4th plan, plan D, refer to a graph or a table. And I'm going to kind of stress the table a little bit, the idea of plugging in numbers, because you might not always just have a graphing calculator. It's probably going to be a no calculator type of question. But I'm going to show you graphs, just kind of, you should be familiar with these graphs anyways, but just some things to think about. So 2 examples, well, I'm actually going to do 4 examples. 2 of them are related on each side though. So I'm going to look at the limit as x approaches 5 from the left of the square root of 5 minus x. And then I'm going to do limit as x approaches 5 from the right of the same function, 5 minus x. And then on this side, let's look at limit as x approaches 3 from the right of 1 over x minus 3. And limit as x approaches 3 from the left of 1 over x minus 3. So your choice. Feel free to pause the video and think about these on your own. I want you to think about plugging in numbers and not go straight to a graphing calculator. See what you can do. Or we haven't spent as much time with these, so you could just keep listening. Here we go. Okay, so let's look at the square root function. Okay, if I plug in 5, if I'm just going to plug it straight in, 5 minus 5, square root of 0, well, that's good. That function value exists. But square root functions, depending on the type of function, it could be, it's only going one direction. Could be going this way. And they could be going like this. So let's just see, first by plugging in a value, approaching 5 from the left. So let's think like 4.99. So if I plug in 5 minus 4.99, does that value exist on the domain? Well, this would be the square root of 0.01. Well, I could take the square root of that, no problem. Okay, so now let's do 5 from the right. So square root of 5 from the right, that would be 5.01. Well, that's going to get me a negative 0.01, and I can't take the square root of a negative. So approaching from the right is not in the domain. And if you were to graph this function, you're going to have at 5, we're going to have this point, and it's going to only go to the left. So I can, from the left, approach 5, and it will approach to 0. But I cannot approach it from the right because the domain doesn't exist from the right. So the limit as x approaches 5 from the left exists, but from the right does not, and then therefore at exactly 5 does not exist. All right, so now let's look at this other function. I'm going to have a vertical asymptote, so let's see what's happening at that asymptote by just plugging in values. So I can't plug in 3 for x because I'll have a 0 in my denominator. But could I plug in a value to the right of 3? So let's do that. So 1 over 3.01 minus 3. So that would be 1 over 0.01. Well, dividing by something really, really small is going to be big. So this would be 100. Now imagine doing 1 divided by like 0.00001. It's going to keep getting larger and larger and larger. So as I am approaching 3 from the right, as I get closer and closer and closer, the numbers keep getting bigger and bigger and bigger. So this is approaching positive infinity. And now let's approach from the left. So from the left, let's say 1 over 2.99 minus 3. Okay, well that will be 1 over negative 0.01. So that's going to be negative 100. Very similar idea here, except they'll keep getting larger and larger negatives. So this is going to approach negative infinity, which means right at 3, it will not exist because from the right and the left are approaching different directions. So there is our full lesson, kind of reviewing all the different ways to evaluate limits. Good luck with your lesson.